Assalamualaikum. I am Hashmi and I am your tutor. Welcome to Intermediate Part 1 Math Series. Today is our lesson number 3, and in previous video we have discussed with the real number and the types of the real number. And specifically about the type of real number, we have discussed the rational and irrational number. So in this video we are going to discuss the rational and irrational number. So are you familiar with these two types of the real numbers? If yes, then continue with this lesson. But if not, then I strongly recommend you to go back and watch the last video. So let's get started with today's lesson, which is about the rational and irrational number. So we have an example in your math book, which is about you have to prove the number which is an irrational number. So just recall the definitions of rational and irrational number. So here I am just quickly review the definition of rational numbers and irrational numbers. So the terminating and recurring decimals are the numbers we can define as a rational number. And the irrational number are those numbers which cannot be terminate and non-recurring decimals. There is another definition for the recurring and rational and irrational numbers. So there is a definition, the number which can be written in the form of p by q, and where p and q belongs to the integers and q is not equal to 0. Similarly, the numbers which cannot be written in the form of p by q, so we can call them as irrational number. So that's it. There are definitions for rational and irrational number. So let's move for the example. Okay, we have an example over here. Square root of 2 is an irrational number. So in maths we can prove any proof by method like we have a supposition. We have supposed anything which is contradictory to the original statement. So here we are going to prove this statement as a contradiction. Now we have to suppose that square root of 2 is an rational number. Okay, so I'm going to write over here square root of 2 is a rational number. Okay, now what will happen if square root of 2 is a rational number? Yes, now you have to write the definition of the rational number. Okay, so we can write square root of 2 in the form of p by q. Okay, and as we know that p and q belongs to integer, whereas q is not equal to 0, right? Now if we are going to square on both sides, so we will get 2 over here, and this side will become p square by q square. Okay, hope you understand this. And again here q is not equal to 0 and p and q belongs to integers. Now if I am going to simplify this statement, so what will happen over here? I am cross multiplying this. 2q square equals to p square, right? So now you have to rename this equation as on 1. So from this statement we can deduce result. Okay, or we can rewrite like this. This statement p square is equal to 2q square. So name this 1. Now what will you deduce from this statement? P square is divisible by 2. Okay, p square is divisible by 2. Now I'm going to write the statements over here which we can deduce from this equation 1. Number 1 statement is p square is divisible by q, as it is clear from here, divisible by 2, right? So if square root of any number is divisible by 2, so we can say like that p is also divisible by 2, right? Now if we can say that p square is divisible by 4, we can say like this. If I'm going to write over here, p square is divisible by 4. So the value of p square, if we are going to substitute over here the value of p square, which is 2q square, so we can write like this: 2q square is also divisible by 4, right? So we are going to write this: q square is divisible by 2. Okay, if we are going to remove 2 over here, so this q square will be divisible by 2, right? Now again the same theory, if the square of any number is divisible by the 2, so q is also divisible by 2. Okay, now you can see p is divisible by 2 and q is also divisible by 2, right? As we can say, the rational number, in rational number there is no common divider, right, other than 1. We have an information from our previous grades that we can write like this, p by q as a rational number. So p and q have no common divider. Okay, so we have no common divider other than 1. So here we can see like p and q. Okay, p and q have divided. Which one? Yes, have divided 2 other than 1. Okay, so it means other than 1, it means p and q belongs to square root of 2. So it means square root of 2 is not a rational number. So the number which is not rational number, it comes in the category of, yes, right, square root of 2 is an irrational number. Now just quickly review this lesson, what we have done in this lesson. We have a number which we have to prove an irrational number. So we have taken this irrational number as a rational number on the contrary. Okay, so according to this, we have a definition. Square root of 2 is a rational number. So we have definition according to rational number p by q. And p and q belongs to z and q is not equal to 0. So we have put the value p by q over here. Now I am going to square on both sides, which will become square root of 2 as 2 and p by q as p square by q square. Here I have cross multiply to make an equation. So which will equal to p square equal to q square. Now we have 4 statements. Okay, so square root of any quantity which is divisible by 2, it also divisible by the same number. So from these statements we have reduced that p and q have one more divider, which is not 1. Okay, so this statement justifies that p is not a rational number, because if p is a rational number, then there must be one divider which is 1. So this statement says to us square root of 2 as an irrational number. Okay, so you have another example in your book, which is you have to prove square root of 3 is an irrational number. Now it's your assignment. You have to do it by yourself and let me know how much you understand from my lesson. Hope you enjoyed this lesson. Thank you for watching. See you in the next lesson.